power. Hello, microphone.
How does it know to use your iPhone as a source? Crazy.
Built-in Apple. Why is it not showing up? Okay. There we go. Okay, now we should have audio. Okay, folks, hopefully you can actually hear us now. Let's double check this. Go on to YouTube. Go to Utah Rust. We're searching. Search. There it is, live, and still titled Sending Data to Channels. Well, I need to go fix that data. I need to figure out how to fix the data ahead of time. Okay, we're streaming, we're live. We'll also start up Zoom.
Is this supposed to be pointed at us?
It's a conference room mic, so that'll catch everybody.
Oh, got it.
All right, I need to log out of my work account, not in, to other account, Zoom. Okay, I'm screaming all of my passwords. The thing is that these are not actually showing the passwords. Yeah, I should have this up beforehand. Sorry, everyone.
No worries.
It's all part of the warm and cozy atmosphere.
That's right. It's the rustic charm of our meeting.
Funny.
Yeah, that was good.
Oh, I didn't even realize. Oh my gosh, I've got the puns like embedded in me now. This is amazing. I feel like I've just leveled up.
There's a lot of puns around the Rust language.
There are.
Like say, oh, I'm a little rusty. Huh?
Well, you know, it's not exclusively the Rust language. I've noticed it's sort of an industry thing. You know. Where is Zoom?
I feel like the Go language has a lot of those too, but people don't take nearly as much advantage of
Yeah.
the puns that can happen.
Yeah.
Or maybe they did in the early days, and now they're like, okay,
All right. Why isn't it, you know?
Nah, reel back a bit.
everybody, let's go.
Too much, you guys.
Okay.
We're scaring people off.
There we go.
What's going on?
Now I can actually go into meeting. Where's the meeting? The meetings. Meetings. Hey, look, there it is. That's the one.
Wow.
Okay.
Oh.
So let's see. We will share.
You want to unmute yourself?
I should unmute myself. That is a good idea. Unmute myself. Okay, sharing the screen, unmuting myself. And then, let's see, on the Zoom, we could also let it have some video. So it'll just like also grab that same video. So the Zoom will be similar to the stream, but a little different. Okay, let's see if we can hide Zoom. Hide Zoom, there we go. Welcome everybody. This is our very small Rust session today. We're just having a little bit of Bevy ECS introduction, and then we'll just talk shop the rest of the time. I don't really have a very large presentation today, and yeah, you know what? Ugh, I shouldn't be mirroring. I apologize. A little bit more setup. Let's see. So, gotta go into displays. Displays. Stop mirroring. Where is the mirror part? streaming software, it would be so much better. Oh, streaming software, we need to switch that to have a screen as well. That's not the right screen. The big TV doesn't seem to be the big TV. Try that. There we go. Aha! There we go. So we're streaming the big screen, and you guys can see the big screen, and Zoom can see the big screen, and so that's as close as we're going to get. If there's something that's still messed up, then I'm sorry. Okay. So now my dock is gone. Come on, dock. There we go. We'll open up the slash. Oh, there we go. Cut the slide. Boom. Welcome everybody to the official starting page of the presentation for today. Yay! Alright, so this is a shortened proto version of my Bevy game engine session number 1 of 6. Well, I mean, it is session number 1 for the meetup. I'm hoping to turn this into a real course, like my other courses. Bevy's a little bit more challenging in a lot of ways because a lot of Bevy changes really quickly. But I think it'll be slowing down here in the near future. And a lot of the concepts are still long lasting, especially the ECS, which we're going over today. So I'm hoping to make presentation parts that go over the concepts that are longer lasting, and then I'll just have to update the code parts. But we'll see. Anyway, or maybe I won't end up making a course after all, and it will only be you guys who ever get it. Could be that too. We'll find out, won't we? Anyway, I would love for you all to ask me questions, so feel free to stop me at any point. In case I actually do make a real presentation out of this, the questions really help me to figure out where the rough spots are. You can give me feedback in the end, or ideas for things I could do better, or things I could do worse, or whatever. Yeah. So what's Bevy? Bevy claims to be a refreshingly simple data-driven game engine built in Rust. Bevy is aiming to be a generally usable 2D and 3D game engine along the lines of Unity or Unreal Engine. I believe it is currently the front runner as far as Rust game engines in this general category of sort of general purpose game engines. There are more focused game engines that are I'm a game engine for this specific thing in Rust. But this is really the forefront of the general ones. It hasn't hit 1.0 yet, so there are rough edges. I mean, notably, it doesn't even have an editor yet. So it's all 100% pure code right now. Still, it's got a lot of things. It's about 4 years old. It has had a ton of work put into it. It has a great, vibrant community, lots of people working really hard on it. Full disclosure, I am a Bevy contributor. I've contributed code. I'm also a Bevy sponsor. I have sponsored it financially, so I might be slightly biased. So take that for what it's worth. Anyway, let's go through an overview of the major features. First, it said right up front that it was data-driven, right? And that means that the engine itself and the game logic that you'll write for your own game will use Bevy's ECS, or Entity Component System. This is really what makes Bevy fast and capable, besides just being written in Rust. It also simplifies the game engine design, and by extension, the game design that you'll do. And this is what our session today is going to focus on. So I'm going to just stop here, and we'll come back to this after I sort of give you an overview of the other big features. There is a 2D renderer for 2D games with features you would expect, like sprites and sprite sheets and dynamic texture atlases and 2D cameras and 2D textures and 2D materials. It also supports custom shaders and render pipelines built on top of Bevy's render graph. And of course, not all games are 2D, so Bevy also has a 3D renderer with all the fancy features you'd expect, like lights and shadows and cameras and meshes and textures and materials and GLTF loading, custom shaders, render pipelines. You can even split your screen space into multiple logical windows powered by different 3D cameras or even 2D cameras, a mix. So you can make mini maps or multiplayer split screen or a monitor inside of your game displaying another scene or whatever you need, portals, all sorts of cool stuff. The render graph enables you to build composable and reusable render logic using render graph nodes. They tout this as like a, hey, like if you want something that's like super fancy graphics wise, you can set up this set of stages to like do what you want. I've never got into graphics side of things that much, but other people have, and it's pretty cool. It makes it so that Bevy, like there are Bevy plugins that are working on augmented reality or virtual reality and stuff like that, and this is really useful. The rendering is not tied to any specific graphics API. For example, it'll use Vulkan on Windows and Linux. It'll use Metal on Apple. It can also use WebGL. As an aside, you can actually compile Bevy games to WASM as well and run it in the browser. And there's also, what's the other one? WebGPU, or is it WGPU? I always get confused on the acronyms and all the graphic stuff, but it it uses Winit under the hood and what else? I don't know. It uses all the standard Rust stuff, the good stuff under the hood.
So not OpenGL then, or?
No, OpenGL's days are kind of over. Like Apple deprecated support several years ago, and they're going to remove it soon. So like if you and then there's Vulkan available on Windows and Linux. Not to mention, of course, DirectX on Windows. I think they're working on a DirectX backend as well. So it's like.
Yeah,
do
that's
OpenGL,
kind of what
right?
that's kind of what I've heard, but I'm not really into it.
Yeah, and I'm not real into the graphics scene, but it sounds like a lot of people are really pushing the. Is it WGPU or WebGPU? I always get confused. Which one of those is sort of like a new generic standard for like browsers and mobile and stuff? I don't know. Seems like might be the new OpenGL, but don't quote me on that. Like I said, I'm not a graphics guy. Bevy does have a skeletal rig animation system, which can play multiple animations on the same skeleton simultaneously by blending the animations between them, or blending between the animations. Animations can use blend shapes and morph targets to animate vertices directly, and animations can be imported from GLTF scene files, so that's cool. Bevy is cross-platform, as I already alluded to, and so far supports macOS, Linux, Windows, iOS, and Android. And honestly, I think it would also support your consoles, but they all require various NDAs and legal paperwork and stuff like that.
Have you tried building to mobile?
I have. I
How was
got a thing running on my iPhone before.
Wow. What was the experience like?
Well, at the time, 2 years ago, it was terrible. It was like really, really like you had to follow a lot of instructions, but I hear it's a lot better now. I haven't tried recently because it's just, quite frankly, I think there's still some rough edges.
Yeah.
But I don't know, I could be selling them short. I haven't tried these recently, so maybe they've ironed that all out by now. I've really been focusing my attention elsewhere lately. I really want to get back into my Bevy stuff because they've been doing awesome stuff, and I really miss my game projects. Bevy supports keyboard, mouse, and gamepad input out of the box, which is cool. It doesn't yet have action mapping, but that's on the big to-do list when they hire Alice. If we were talking about the whole Bevy nonprofit org and stuff like that, how they're working on hiring Alice full time, and that's one of the to-dos on Alice's list. But Bevy has its own UI system. It's currently being overhauled. That's one of the reasons they haven't done the editor yet, is because they're overhauling the UI, and they're going to build the editor with the UI, so, dependencies. But that's like super top of the list as well. Everyone's talking about the editor, so excited for that. Bevy has a concept of scenes, which enable you to create instant save, load, and hot reload portions of your game. That's super cool. What else? Sound. Bevy has a sound subsystem, but admittedly, if you want anything fancy like spatial audio or composable audio effects or anything like that, then you should use a third-party audio plugin, which they do have. Bevy Kira Audio or something like that is the But if you just need to be like, I need to play sound effects and music, and it's just all global sound, like, that's there. Bevy has really nice compile times. They call them productive compile times. They have like a fast compile configuration where they're like, set these settings depending on Linux, Windows, or Mac OS. And that should get your compile times to between 0.8 seconds and 3 seconds for recompiling your project, which is pretty dang decent.
Yeah, that's great.
And they tout that as being 10 times faster than most competing Rust game engines. Bevy is free and open source. It's dual licensed under the permissive MIT or the Apache 2.0 licenses. And you'll see that a lot in the game engine ecosystem in Rust. Having a dual license between MIT and Apache 2.0, like almost everything is.
Do you know what Godot is?
Godot, yeah.
Is that also the same licenses?
Well, it's not in the Rust ecosystem, so I haven't actually looked
No, I'm just
at
curious
the license.
if they're different. Yeah, no.
I don't know what Godot's licenses are. No.
I don't think so. There's some.
I think they're Apache. I just don't think
Are
they're
they?
MIT. Yeah. But I'm not sure. I'm not sure.
Yeah, fun fact, Cart actually was a contributor to Godot, or I don't think he was a major contributor, but he had contributed code to Godot and had used Godot to build at least a fully functional game, if not multiple games, before he came to Rust and started Bevy. Cart is the guy who started Bevy. Carter.
Could you take a tangent to tell what the secret sauce is for those compile times? If you know.
Well, a lot of it is that
It is
you use a
MIT?
custom
So it's
linker,
not
like
Apache.
mold.
Okay.
That's a lot of it. And then they do a lot of stuff like saying, compile everything else in release mode. That doesn't really speed up your other compile time. I don't know, we can just go check real quick.
I just heard they avoid macros because that's how a lot of libraries avoid compile times. It's just they avoid.
Yeah,
generated
and I know
code.
that they very carefully partitioned Bevy itself into crates to try to make it so like if they did have macros, they tried to hide it down a couple levels.
Yeah.
To try to keep the macros away from you. So like we're not interacting with many macros. So yeah.
Do macros increase compile times?
Yeah, because macros, it's like metaprogramming, right? It's like, oh, every time you hit a macro, it spit out a whole bunch of code, and then it's all
Which
harder
might be
to
other
cache that,
macros
right?
and-
You're like, oh, we're gonna recompile it all every time.
You have to actually run the code that
Welcome.
generates the code, and then that produces more code to compile.
Yeah, yeah. So macros definitely lengthen compile times. But yeah, let's see. Talk about that. Community. I did mention there's an awesome community, a really busy Discord server for Bevy. It's got like thousands of people on it. You can always get someone to respond about something. Honestly, it's to the point where like, once you get past a certain busyness factor on Discord, like I can't really use it anymore because it's like, okay, like
Yeah.
I can go there like if I have a question, I'm gonna sit and watch it. But like, if I come back to it in an hour, every single channel's had 40 lines, and I can't handle the back scroll. So,
You have to like search for your message to see if somebody
where
responded
was my
to it.
message? Yeah, exactly.
Versus when people don't use the reply feature.
Oh.
So it's just like they're responding to you somewhere in the noise.
Oh, I still every time I try to have like a threaded conversation in Discord, I'm like, wait, this is very not Slack. This is not very threaded. Anyway, it kind of sort of is if they enable them in the channels, but I don't know, it's weird. All right, plugins. So Bevy has lots and lots of plugins. In fact, Bevy is built like from the ground up as plugins. Like the plugin architecture is fundamental to the design. All of Bevy itself, what we think of as like core Bevy, is all plugins. Like it's plugins all over down. So you can literally turn off any parts of the system you don't want. Oh, you don't want to use input handling? You turn it off. You don't want to use rendering. You want to have a headless game server? Turn off rendering, right? The entire graphics subsystem, and so on and so forth. Like perhaps the only thing that's not like turn offable is like the ECS, and that's what we're going to talk about today.
What would a headless? What would headless be used for?
Server, like a multiplayer game server.
Oh, I see.
So all the logic is running in the ECS.
But like, there's no one to display a viewport to.
Mm-hmm.
But like, you still want to like run really similar code.
Do you have like a network plugin to do the connections?
There are network plugins. There is no network stuff built in, and I honestly haven't found a network plugin to recommend. Networking is hard. I mean, that's going to come way late stage. So right now, if you want to do networking, you're kind of on your own. Like, there are some things, but there's not like everyone just goes and uses such and such. I mean, not to mention that when you're talking about networking, the style of game you're using heavily influences what your network architecture needs to be. Like, there's a huge difference between, I need a centralized server that like contains all the logic, or no, I need every single thing to like do the same simulation as everybody else. And maybe they do also have a central hub where they pass controls input through, or maybe they don't. Maybe they need to talk directly to each other, or maybe it's just a turn-based game and it really isn't like performance set, or maybe it's a twitchy Street Fighter game and you need rollback logic. Like, there's so many things.
I've heard the craziest story. Do you know the Helldivers game that came out recently?
No.
Just heard about it.
Yeah, so they have networking logic that workloads the AI, because there's a bunch of like AI, like you can have hundreds to like possibly thousands, and so they workload amongst the different PS5s or whatever console you're working off of, and then they'll bring it back, and then that's what like will be like the central authority of what the AI is doing. But it's crazy. I've never heard of that.
Like
Nice.
they're using the compute of the
Of the
consoles.
user for the AI, and then they'll bring back the decisions that the AI has made,
Oh wow.
and then they'll send them back to like, now it's attacking you like this.
Interesting.
Yeah.
Wow.
I like it. Bit of hot chocolate. All right. Well, that's it. Okay, so that's our like Bevy overview. So yeah. Session 1. Here's our ECS portions. Okay. So now, hopefully, everybody's interested. Let's talk about perhaps the most unique aspect of Bevy. It is the ECS, or Entity Component System. So when Bevy claims that it's data-centric, it's talking about the ECS. So let's start off talking about entities here. So an entity, I'm ashamed to say, it took me months to figure out, it is an ID number. That's all it is. It's just an ID number. In fact, it's a GUID. It's a globally unique ID number. And you'll never see the number. The number itself isn't important. The important thing is just that it's unique, and that it deals with it under the hood. The end. There's entity. Okay. ID number. Should use that. Anyway, anything you want in the game is an entity. So you want a sprite, it's an entity, right? You want a bad guy, a menu button, a door, a box, whatever. They're all going to have an ID number. Okay, so we use the commands struct to spawn entities in our game. Of course, like, spawning just an ID number isn't super meaningful. So that's where our components come in. So components make things interesting. They give them, somewhere to store data, something to think about, some representation. In Bevy, all components are structs. So you just make a struct, and that's going to be your component. And you can make a bunch of different kinds, and these components represent some aspect about an entity. What it has, or what it does, how it behaves, where it is. You just store all of your data related to your entity in your components. So you attach your components to the entities. For example, let's say that you need your sprite to be at a location in your game, pointing a certain direction, and it needs to have a certain size. Those are 3 really common aspects that they bundled into one component called a transform. You might have heard about it if you've ever used any game engine. Most of them will have a transform. It has your translation, rotation, and scale all built into it. That's a really common component. That's a built-in component. There's a whole bunch of components that are just available that you can just use. And then, of course, you're going to want to make your own as well. So let's see. I should have been advancing the slide while I was talking. Translation, rotation, and scale, our transform. Okay, so let's make a component. So here we make a component. We call it fish. So it's going to represent the color of a fish. We're going to attach it to something that's going to be a fish, and it's going to have some specific color. We're gonna use that color for some reason. Maybe we'll tint a sprite that color. Maybe
So
it's not already the color.
So the struct is a component, not an entity?
Correct. So what we'll do is we'll create an entity, we'll create an ID for this and then we'll attach the component to it.
So
And-
one entity, you can have many components.
Exactly. You can have a whole bunch of components attached to it.
And components more often in some game engines they use a different term. What's the term?
Depends on the game, I suppose.
Yeah, where it's kind of like capabilities or something like oh, this has a sprite component. I think they say component in like Unity.
Component's used in a lot of ways. It's got a sort of a specific, slightly different meaning in ECS versus like the actor model that Unreal or Unity use.
Yeah, because they usually say like, oh, you add a sprite component to this class, right?
And in their model, you can think of the actor as basically a struct, and the components as the fields of the struct.
Right.
And that may be an oversimplification, but the point is like it's centered around you have all the data for the actor together, whereas in ECS, we'll talk about it in a couple minutes, how the components get stored together in some way, so that like when you're iterating through them, you get this nice cache locality where they're all going to be right there available to the CPU right now without having to go back to main memory. Whereas when you're dealing with the actor model, it's like, okay, you're very rarely dealing with just one actor, but you might just be dealing with, okay, I need to move everything. So I'm going to go through all the different actors and look at all their tons of junk just to pull out their location and deal with it, right? And you can see where that can get really inefficient memory-wise because it's like bringing in, oh, these big actors with all this memory, but they can only fit so many of them into the CPU cache. And you got to go get some more actors. That means you got to flush your cache and get some more stuff from main memory. You know, big hit to cycle that. You know, getting stuff from memory takes a lot of time. Why is Zoom popping up? Hello, Zoom. Oh, maybe it's because of chat. We got some chat questions here. Robert Stewart says, what is the UI going to be used for besides the visual editor? Well, you can use it in game. So you can use it for your heads-up display or your menus or whatever you want to use UI for. And then they're also going to use it to build the editor. So, I mean, ostensibly, you don't have to build games with Bevy. It's anything you want, simulations, and use the tools for. So, you could build apps with the, not always the right tool for the job, but you could do it. Let's see. Sounds like the kernel mailing list. I'm not sure what he was talking about exactly. Oh, probably the Discord server. All right. Let's see. I'll try to keep an eye on. If that pops up in that, oops, should mean that's not what I was trying to hide. Hide Zoom. Good heavens. Sorry, guys. Back to the slide. Okay. Let's move on here. So here's another struct, so like another component we'll work on here. We'll call it a player struct, and our player has some health that may go up or down, so we'll store that in the player struct. You could also use these components like markers. Like the fact that you have a player struct with some health means that, oh, I'm a player, right? That means something. Maybe players all have input, like mouse or keyboard or gamepad or something like that, whereas the other, enemies or whatever might not. To use a struct like this as a component in Bevy, you do need to derive the component trait for the struct. So you do need to set this attribute in front of anything that you want to use as a component. But then you're good to just use it wherever components are used. All of these things like this component derive and all of Bevy stuff is brought into scope through Bevy's prelude. So first thing you're going to do with any Bevy project is import everything from the prelude, and like 80% of everything you'll ever need is right there. Okay, so here, we sort of alluded to this a little bit, but if you ever used a relational database like PostgreSQL or MySQL, then it might help to think or visualize the entity ID as an ID column in a table, and then all the components as columns. I mean, I know it helps me anyway. And then you can think of, okay, we're going to talk about querying the ECS. You can think of it like querying a SQL. It's like, oh, well, okay, there's a way to specify the different components or columns that I want to get out. There's a way to filter by what columns or components they have or don't have, or the values of them, right? So that it's very analogous. There are, let's see, for example, we went, okay, I want to say, may want to get the transfer. So here I have like, oh, there's a transfer component, there's a player component, there's a fish component. Like, what if I want to just move all the blue fishes around the screen? Well, I'll make a query that pull up the transforms and for the ones that have blue fishes, you know, and then I'll modify them. So we write that query inside of a system. This brings us to the system portion of an ECS. And systems are just functions. They're functions that Bevy will call usually once every frame, right? So the way game engines work is you need to do something every single frame. So usually about 60 times a second or about every 16 milliseconds, you gotta compose a whole frame to show on the screen, like do some logic. So it's gonna call all of your systems each frame. And then your system can go and look at stuff and do what it's gonna do. All right, so for example, let's say we want to move our blue fishes for reals. So let's do it. So this function here has a query parameter that says we want to access transform and fish components from all the entities that have both of them. And then furthermore, we want mutable access to the transform. See the mute in front of the transform, but only immutable access to the fish. So this is really, really, I don't know, clever is not the right word. This is like beyond clever. Like this is like, I was watching ECSs evolve in the Rust gaming ecosystem for like 4 or 5 years. And this is like, I don't know what technically generation it is or whatever, but it felt like a 6th generation ECS. Like it built on all these attempts to like do this. And the way this one works is it uses these types to specify like you'll notice these are all types, right? We're all just, on the left we just got this query parameter, and on the right we're just giving it types, and the Bevy ECS looks at the types and works on the type level and figures out like how to do everything under the hood for you. Like a lot of other ECSs, earlier ECSs, you had to do a lot of like telling things what to do using like macros, and you have to like specify this, and the other thing, and you just store it like this, and give me access to this, and like, it would be like this, it would start looking like this. You got macro after, like derive after derive after derive after derive with all these things telling it like extra stuff so that you could like build it up and make it work. And to me, Bevy just like got to this point where it's like, oh, it's just magic now. Like, I'm just gonna put these types here, and it's gonna be like, oh, I know what to do. And it's pretty cool. So anyway. Sorry, just fanboying a little bit. Here's just like an equivalent SQL query. Well, yeah, pseudo equivalent, right? It's like, okay, I'm going to select the transform of the fish from some table where transform is not null and fish is not null. Like, that's probably the stuff.
Curious if you ever think like, right now the select transform fish from some table, that's kind of like the query part of the function, like the parameters. Do you think they'd ever have like the where part be in there as well? Because right now we're just manually looking through each of them.
There's literally, you can add with and without.
But would that help with like saying, like, because you're filtering by value right there, where fish.color is equal to color.blue?
Uh-huh. Oh, you're saying like put the value in there?
Yeah, would you ever, because I feel like that's what the SQL statement is saying like where the value is this.
Yeah, I think you've got to do that kind of filtering in the blue. Is that true? There might be some way to like push that up higher.
Yeah.
I'm not sure. I mean,
well, that would be cool if they did have that.
Full disclosure, I'm not an ECS expert. I've never written one, and I have only the vaguest understandings of how they actually function under the hood. But I do know that unlike a database, this information is in local memory. So there's no like storing it in a table file or anything like that. Since it's just local memory, that means we can get a mutable reference to this. Right? We're just going to get a direct mutable reference to the value. So we're going to change the value directly wherever it's sitting in memory. And change it directly. I've got an immutable value to a fish, so we can read it. Can't change it though. That's something you can't, at least I don't know how to represent in the SQL table. I guess there's probably some kind of user permissions things. Anyway, so next up we loop through all the transforms and fishes that the query can find, and we check to see if the fish's color is blue, and if it is, we go ahead and alter the x coordinate of the fish's translation so it moves a little bit. So that's sort of like the basic, like from start to finish. Like, okay, we spawn it. Well, I didn't show you. Did I show? Because I did have a little spawn. There's literally like a spawn function you call to create the entity, and then you attach the component to it with another method, and then you set up a system like this. Query will grab stuff out. You can play with it, and then moves on. So that's sort of like our sort of gone full circle. So the system is really what ties the ECS all together, right? Create entities, attach components, use the components to store the data you need, write a bunch of systems that implement the behavior for your stuff in the game, depending on what the components have in them. And then even better, the game engine manages all the storage and performance stuff for you. So like, you don't have to, unlike SQL, you don't have to define the tables. You don't have to define the schema or worry about any of that stuff. In some ECSs, you actually do have to. In Bevy's, you don't have to. In fact, under the hood, Bevy will optimize the data for maximum cache hits, which usually it means it has some heuristics. You know, it's not perfect, but it's pretty dang good. Where it will try to look for like sets of entities, or the rows in our analogy, that have the same components, and try to separate them into different storages, or it'll try to make these good decisions about, okay, what should I actually put together? Oh, is there always a transform and a fish component together? Well, maybe it actually does make sense to make a table or a vector or something somewhere that actually has the fish and the transform together, and then we'll just put them all, like line them up in memory. Or maybe it doesn't. Maybe we just want to have transforms. Maybe like there's like not enough in common between all the things that have transforms. We'll just store all the transforms together, and then we'll take, there's only like 4 of these things, which is like random things. We'll just stick them all together in a different storage with some gaps, and it's fine because it's small. So it tries to make all those decisions. There are ways to like reach in and like tweak it. Like if you know better, you can be like, no, I want you to do something different. There are some ways to do that. I'm not going to teach any ways, but they're there. So it's pretty cool. It's pretty dang nice. Yeah, anyway, this is like my example. Maybe the ECS would decide, okay, like if I had it like this, you see those nones? It's like, oh, okay, well, they've got some gaps in this table. Maybe it'll switch it to like this and be like, okay, we'll store those together, we'll store that together, and then we don't have gaps, and it's a little bit more efficient to like iterate through it. And probably they're gonna look at the player by itself a lot, and then they'll probably just iterate through all the non-players at a different time, that kind of stuff. So yeah, makes it so stuff is super cache friendly and more efficient. It also, one of the reasons that ECSs are so huge in Rust is that the actor model, the only way you can get away with it in C and C++ is by playing fast and loose with ownership. Like, who owns this? I don't know about you all, but I spent 2 years trying to use Unreal Engine every night for my project, and it would crash, and it would crash. It was so freaking frustrating. And every release, they would fix hundreds of crashes and introduce hundreds of different crashes. And I went and I fixed some of those bugs, because Unreal Engine is available source. So once you sign the NDA, you can get a hold of the source. It's not open source, but it's available source. And in almost every case that I either checked up on where they actually fixed a bug that affected me, and I went and I looked at the pull request, or that I fixed, it was they forgot to check if something was null before they dereferenced it.
Yeah.
Because it could disappear, like something else, a different actor's logic could reach into something else and take something away and it would become null. But like when you wrote it over here, you didn't know that it could ever become null, so you didn't think to check to see if it was null before you used it. But it could, and whenever it hit that, boom, the entire Unreal Engine editor would crash. Or boom, the entire compiled game would crash, just over. It's just not like, you know, it's not like in JavaScript or Python or something where it's like, I'm gonna tell you at this line, right here, you had a problem. And the problem was that it was, no, seg fault.
Yep.
It's just like,
It's like a core dumped.
yeah, it's like, okay, and like if you were a C++ guru, then you could get the core dumps, Unreal Engine's core dumps, which were massive, and you could dig through it and figure out. But I am not a C++ guru. I spent my time learning Rust. And before that, I was doing scripting languages, right? And so it's just like so frustrating. I'd have to like reason about, okay, it's probably right here. And like the bugs I fixed, I figured it out by just like making sure, okay, I can always reproduce it when I do this, and obviously it's calling this logic here, I found it in the source code. Oh look, they're not checking to see if something's null. Change it to see if something's null, recompile Unreal Engine, wait 45 minutes for it to recompile.
Really?
That's a big compile.
It was over 2 million lines of C++ code.
Oh.
Lots of macros.
Really, actually, yeah, there's lots of macros. And then they're like, oh my gosh, I fixed it. It only took me 5 days. And it's just like, I couldn't deal with it.
Were you using blueprints?
I couldn't deal
or
with
C++?
it. Yeah, I started, I went out, I discovered the bugs in the blueprints.
Oh, I see.
In the C++ portion, implementation of the blueprints. I was already using only blueprints to try to avoid that kind of stuff because I didn't know C++ well enough to write my stuff in C++. And honestly, that's when 2016, like when I decided, like, okay, I sat down and like, I'm gonna master a systems programming language. I really wanted it, like when I started out, I really wanted it, my choice to be C++. Because I'm like, Unity is C++, Unreal Engine is C++, all game engines are C++. It was so useful to me, the C++. And I did all this research for a month, and I went through over 50 languages, and I'm just like, oh, C and C++ just suck. I mean, it's just no brainer. It's just like Rust is obviously gonna take them both over. I mean, it's just, there's just no like, how many seg faults have I ever had in Rust? Well, I've had about 3. All 3 of them were compiler bugs. And the last one I got was 2018. So they do happen.
Yeah.
Don't happen to me much. And when they do happen, either 1, you decided to do unsafe code and you forgot to check something. Yeah, that's on you. Or 2, there's a bug in the compiler. Otherwise, it just doesn't happen. So, okay, sorry. That was quite a rant.
Someone could feasibly pay you a nickel for every seg fault you've had.
You know, I wouldn't complain if someone paid me a nickel for every seg fault. Actually, I earned $7 from that game I did publish in Unreal Engine, so maybe they did pay me a nickel for every seg fault. No, not yet.
Not yet.
Not yet. Nickels, it doesn't take a lot of dollars to make it up in nickels, though.
Yeah.
All right, the last little thing we're going to talk about the ECS. This is sort of like ECS adjacent. There's a concept called a resource, and this is just a struct that you sort of stick it. It's like a global struct. It's like in your system, you can say, I want to access this resource, and it'll just give it to you. But it's just like sitting by itself. So like think like high scores. Like maybe like there's nothing in the game that makes sense to like attach it to. Like I just want to store some high scores. So maybe it's just a resource.
Would you put like sounds or textures in there?
There's an asset server resource.
Okay.
There's a built-in time resource. Like a bunch of like the engine internals are resources where it's just like, oh, everyone needs access to this occasionally, but it's not like something that exists in the game. So yeah, like all that like extra infrastructure, there's a lot of built-in resources. I don't see people use resources a whole ton. It's usually just like those edge cases where like, okay, like if I'm not gonna give it a location, right? If I'm not gonna give this a location, and there's only ever one of it, maybe it's a resource, right? Because if it doesn't have a place, what is it, right?
Yeah.
And if there's and there's only one. Now, if there's more than one of it, then it can't be a resource. I mean, you could make a resource that's a vector of it. But yeah. And that's it for the presentation. I was gonna like run us through like a simple like let's actually code it up real quick. You guys want to do that?
Sure.
All right, let's do it.
Real quick, could you speak a bit more of what you understand about how queries work? Because of all the brilliance of Bevy, that's one thing that I'm like, that makes me nervous because it's so magical, right? And
So what do you
magic?
I'm not sure I understand the question.
I get the question is, how do they work? And the reason behind the question is, for me, it's like, oh, that's magic, and that makes me nervous because I don't understand what the magic is doing under the hood, and I prefer to know that, you know.
Well, I mean, conceptually, it's pretty simple.
Right.
Conceptually, they're
like as a user, it's pretty simple.
Conceptually, they're like, well, I'm talking about like the back end. Conceptually, it's simple. Like how they implement it is not, but conceptually, it's like, okay, we're gonna make some vectors of things, and we're gonna figure out for you what it makes sense to make vectors of, and then we'll just do it for you.
And like, does that happen at like compile time? Does it look at the types and like create some runtime code that maps types to like places in a vector, or?
A lot of it happens at compile time, and I mean both. Some of it happens at runtime, some at compile time. I know that, for example, looking at your systems is heavily macro based. That's not the right way to say it. Okay, they use macros heavily to reproduce a bunch of blanket trait implementations that then will match all sorts of different function signatures. And then those trait implementations match at compile time. So the code's really all set up. So I guess what I'd say is at compile time, it spits out a whole ton of macros, but then only a couple of those are actually going to match.
Bunch of traits, you mean?
Done. So it's gonna use macros to spit out a bunch of traits. Thank you.
So the traits have a bunch of type signatures, and then some of those are going to be the systems that you actually wrote.
Yeah, and a lot of that actually then translates into compile time magic, if you will, because the traits that they wrote are blanket implementations for like stuff that looks like this. We're gonna write in a default implementation for this that'll just work. Does that make sense?
Default implementation for what?
For how you plug it into the actual ECS backend.
Okay.
So like the default, so for systems it would be how we call this stuff. And then for like the components and stuff, it's gonna be like how we store this stuff. Right? And I don't know how much of the stuff like choosing storages, I don't know how much that happens at compile time and how much of it happens at runtime. I do not know that much.
Okay.
But does that answer your question a little bit?
A little bit, yeah. It's a teaser. I mean,
it really is.
I feel like I would love to go and like find out what's going on.
Well, and I encourage you to do so. Like they have written they did a lot of work on the ECS over the last 4 years, pretty much constantly, and they've had some really huge changes that they did these really big, nice write-ups for. Like not only in the release notes, but like if you go to the pull requests, way in depth, tons of discussion, lots of explanation. Then they'll come back with like okay, here's a new PR with from everything we went through in this other discussion. Now we're gonna do it this way. So there's a lot to read. Like it's really cool. And let's be honest, I probably said something wrong here. But conceptually, it's going to be close enough to get you started, and then you can go figure out what I actually told you that was wrong, and it'll be like, oh, it's so high level and vague, it doesn't really matter how wrong you was.
I have another question just on experience.
Yeah.
You said you used 2 years of Unreal. What's the has there been what's your perspective on the two communities, and how easy was it to find questions and get those questions answered?
So my experience with Unreal was as a solo developer.
Yeah.
And at the time, it was 2016 and 17. They touted themselves as like indie developer friendly, but like I think that was a real big that felt like a big stretch to me. Like support, like it's very corporate, right? It's like you got to sign an NDA to get access to the code, and like it's literally a corporation you're licensing it from, and you got to go to the corporation for support, and they have forums, but most of the time nobody answers on the forums, so you go to their support guys, and if you're one of the lucky 10% for the day that actually gets an answer of some sort, a lot of times they misunderstood your question, or they gave you a useless answer, or they just pointed you to docs that you already read that don't actually have the answer. It was a lot of frustration, and it really felt like they had a big release. I remember I was so excited. They had this big release with we support Apple TV now. And I had an Apple TV. I'm like, oh, it's so cool. They're working on my Apple TV. And it didn't work. And when I went to support, they're like, well, just have one of your C++ guys just go write an Xcode project then. And make it work. Well, I don't know how to do that. What do you mean, one of my C++?
One of my guys. Yeah.
It really did feel like what they expected you to do is one, you needed a team of 40 developers, about 7 of which are dedicated to the engine and fixing the bugs or adding features that you need. And then the rest of them are going to do your game. What do you mean you don't have one C++ guy, I'm a solo developer. Well, sorry. But you said it supports it, and it doesn't work.
Yeah.
And they're like, oh well. 18 months later, they actually fixed it so the generated Xcode project actually did work on the Apple TV. But then I had other bugs, and it was the same story. It's we'll just have one of your guys go fix it. Find it and fix it. I'm coming to you because I can't find it and fix it. I'm not a C++ guru. I'm not full time on this. I can't become a C++ guru. I can't figure out all 2 million lines of your engine. I got this specific bug. I can give you all the code. Can you help me out here? And it's just no.
Yeah. Sounds like you need to
start
a company.
You're just a little guy. You're not making us any money. It's okay. Whereas with Unity, it was just silence. It was even worse. I did Unity for 2 years before on Unreal Engine.
Yeah.
It was just hit a bug. Go well. Work around it. You can't. There's no code to look at because it's all closed source, and just good luck. There's no one to turn to. You go to their support, and their support is just nothing. Give you nothing.
Is that source available as well, or whatever it's called?
It wasn't when I did it.
Oh.
For me, Unity was
Unity is-
2014, 15.
Wow.
So anyway,
That's bizarre
the
to
whole
me just
reason,
now.
the reason I wanted to master a systems programming language was for my game projects, really. That was a big part of it, right? And then I go into Rust. I'm like, okay, all the game engines are going to be Rust eventually. And I totally bought off on Rust. I'm like, okay, but there are no game engines in Rust yet. This is 2016, 17, right? There was a little bit, but they were crappy. And so it's okay, well, I want to to use this language. Language is fun, whether I'm doing game engines or not. I want to stay in, and I want to ride the game engines up and get back into it. So that's why I started teaching Rust. It was a way to force me to learn it, use it, keep up, stay in the community, be engaged, and then my teaching kind of took off in a way. So I'm still hoping to one day turn the teaching into a real job, day job. It'd be cool to have one job again. It's a little bit frustrating that my teaching's taking over my spare time instead of doing my game projects. Yeah. I'd rather get it so that the teaching was the day job and then the game projects were my projects again.
I was gonna hold off on this question until more at the end of the presentation. We've kind of already hit this topic anyway. So I am a person who knows how to work hard and has worked hard in the past because other things have required it of me. like
Mhm.
school, like work, whatever it is, right? And when someone else is there being like, you gotta do these things, I'm like, I will do all the things. And it's great. I don't struggle with that. But when it comes to like just wanting to get better at a skill that isn't like directly like some outside obligation is asking me to get this done, right? I just struggle because I like, on the one hand, like it's important to me as a developer to grow and to learn and like to feel like I have a really good handle on things. And I'm really interested in stuff like this, like different learnings and different projects. At the same time, once I finish work, right, once I get done my responsibilities, I find that I just don't work on the stuff that like I'm even interested in, right? I see it, I'm like, that is so cool, I would love to do it, and I just don't do it. Like, where do you, how do you do it? How do you do it?
Well, first off, I would say me too. Because I don't do it all the time. You can't do it all the time. I mean, maybe there's a few people in the world who can be on all the time. I can't be on all the time. Like, in fact, like, there's periods in my life where depending on what's going on in my personal life, maybe I don't teach, I don't do game projects, I don't do any programming after my day job for weeks or months. But for me, like, I have these, for me, it's tied into my career, I guess, in one sense, and it's sort of tied into my dreams in another. Like, I've always dreamed, like, the plan when I was a kid, you know, you want to be a president, or you want to be an astronaut, or you want to be the queen, or whatever. I wanted to be a game programmer. I wanted to make the games that I was playing, right? Now, a lot of us start with that dream and then run into the reality that making a game is nothing like playing a game. There's absolutely nothing like. But it turns out I also love programming. So that turned out to be okay because I love programming too. So I was able to sort of like cross that divide. Be like, oh, this is something like playing a game, but I'm already a programmer. I love programming, so that's okay. And I really just, you know, I didn't even start this until I was 27, till I had 2 little kids, and my oldest one was like old enough where I could like sit her on my lap and she could like do stuff. And that's where I sort of like got back into the, oh my gosh, I can make this and like she could play it. And I like got the vision back and got started. By 2007 it was Python. Tried to make games in Python. Pygame, Piglet, and stuff like that. They weren't really game engines. They were more like media frameworks. And anyway, history. But I don't know. This isn't a me question. What do you guys think?
Short answer: have kids.
Have kids. Yeah. Okay,
Have
there you
kids.
go. They were also a big obstacle.
My experience is, especially when I started programming professionally, like I'd be coding for 8 hours a day, and I just straight up didn't feel like writing code once I clocked out.
And that's okay.
And that's what I'm getting at is that, like, just learning to accept that and be like, I have some free time. I feel like doing something else instead, and just accepting that has allowed me now to be to the point where, oh, here's some programming thing I want to do on the side, and I'm more excited about it, and so I will spend my free time on it. So just accepting that some days I don't really want to code, I think has helped me get to that point where when I do want to write code for something, or whether it's solving some stupid problem or doing something more ambitious like a game or something, I'm able to do it because I accept that sometimes I get more excited about it. So so it kind of helps. It helps kind of fuel that motivation a little more.
Yeah.
I have a strategy that has succeeded and failed. So take it for what it's worth.
It's already going.
There was a time when I scheduled an hour of project time.
Oh yeah.
And that was really useful, especially because I had a vision in mind. I was going to make an application, and it was for a very specific use case. And I had friends who I was making it for. I'm like I'm going to make this for you guys to use someday
An audience is a huge motivator.
Yeah, that's a
Like,
good way to
if someone's
motivate it.
expecting you to do something, like give a presentation.
Right. Like, yeah, that external, right? Like school or
Yeah.
work, right? Like, all right, I'm gonna do this for these people, and so I had a good motivation going in, and I was able to like do some experiments that were, made it so that I could see it through. Like I was like, oh, I can see how this is going to be done,
Yeah.
right? And once you get there, you're like, okay, like it's just a matter of sitting down and doing it. And then so I just scheduled an hour a day, and usually the hour starts with, holy cow, I don't want to do this at all. And then you
It's
just,
so true.
you just open the
So
editor,
true.
you just like run it, where was I again? You look at the code, and then you say, you know, maybe that variable needs to change names. Maybe I'll change that.
Yeah.
And you just like get into it, and eventually you're doing it, and then you have an alarm set for the hour, and when the hour is up, you can ask yourself how you're feeling. And if the feeling is, I am done, then you're done. And you're done, and you just do something else.
You know what worked for me actually was, I sort of lie to myself and say, or maybe force myself. I don't know how to think. I'd say to myself, okay, do this for 5 minutes.
Yeah,
You have to.
I've heard
You
that
have to do this for
Right.
5 minutes.
Yeah, and
After
set
that,
a timer.
I don't set a timer or anything.
You can drop it.
I just
Oh,
say
okay.
like, you do it for 5 minutes, and then like, if I'm not enjoying it after 5 minutes, like I'll just stop. And then I go start, and then 3.5 hours later, I realize it's past time for my bed, like way past time. What happened at the time? Because I was having so much fun doing the project, but like, I didn't want to start. Like I just didn't have the motivation, right? I wanted to sit and watch TV or something, and I just found some way to force myself to say like, no, you got to do 5 minutes of this first, and then like I can waste the whole rest of the night. Like it doesn't matter.
Mhm.
And then if I do that 9 times out of 10, that 5 minutes would turn into a fun night of projects. Like,
Yeah.
Right.
and it's so weird because like there was this like no motivation, force myself, motivation that goes
Yeah, you
way
like
up.
get the ball rolling.
Yeah.
And then it's
Yeah,
Let's
and
go.
and there's different strategies. Like I found that if someone would do it with me,
It's true.
that helped. Like if I could get my brother to come, my little brother to come and do stuff with me, oh, I loved it.
yeah.
Love. If my kids were like, if I'm like, oh my gosh, like if I did this, I could show it to my kids. My kids could try it. Oh, huge motivator for starting. Like, or if like, if anyone was in, like it was like, oh, I could show it to so and so afterwards, or like I could post about it, or like just anything that like involved some social something that really broke down obstacles for me.
Mm-hmm.
But,
One
like,
more
yeah.
piece. I don't want to belabor this if it's too much, but that when I talked about how like it was really motivating to feel like I knew how it could be done, learning how to, because sometimes you want to do something and you're like, I don't even know where to start. Finding a way to like break the problem down until you have like a little something you can start on is really useful. In my case, it was like, I don't know how to do this. Okay, that's fine. What about this? I don't know how to do that either. And like keep going until you're like,
Reduce
okay,
the
I can
scope.
kind of get how to do this part, and then
Yeah.
you move from there.
What if I just try to compile this library and call it thingy? Like, what if
Right,
I just
exactly.
try it?
What if I just
See if I can run this thing.
try to run the example, right?
Yeah,
Or try to,
exactly.
Even if you reduce it to enough
Yeah.
that you still don't know how to do it, but it's something that you can Google and find
Right.
an answer to relatively easy,
What if
right?
I could just
So like you're
change
talking
the
about
color?
reducing the scope of it. Yeah.
in my case, it was I needed to make a grid that I could like zoom in and out of and move around, and that was like the big question is like, how do I do that at all? And yeah, just like broke it down and like, oh, there's cameras, and like, okay, with the camera, then I can draw lines. Okay, can I draw lines in a grid? Cool. Can I make them draw in the camera context? How does that work, right? And you break it down, and then eventually it was like, holy cow, I can actually get a grid. And from there, it's like, all right, we're good.
Yeah.
My
we're
challenge
cooking.
would often be, how do I not get distracted by things that don't actually contribute to my goal?
Mm.
I'd
Yeah.
be like, oh, I need to teach this subject. Ooh, I don't understand that word. Ooh, let's read a Wikipedia article. Oh, wow, there's a book about that.
Yeah.
I feel like this has now become ADHD like
Yeah.
therapy session.
Oh, I can't tell you how many nights where I'd work on a game project or I'd work on my teaching and I'd end up contributing a PR to fix something instead.
Yeah.
You're just like, oh,
But you
why
did
am I
something.
doing this? I could have just dealt with it, worked around it. It wasn't that big a deal.
Yeah.
But hey, you're doing stuff.
Yeah, but hey, I was doing stuff, and eventually I get back to it. Okay, we have some chat in Zoom. Let's see. Chat in Zoom. I don't think you can put the values in the query because the values aren't types. Yeah, you can't put them up in the.
That makes sense.
Can't put values in the query.
Mm.
Can you use the ECS outside of the game loop? I mean, the ECS kind of is game loop. I'm not sure. Actually, I think there might be a way to just use the ECS crate and like drive the ECS manually. So I think the answer is maybe, probably.
So like instead of making a call every frame, you have like an event loop.
Yeah, instead of using the Bevy app that sets up the ECS for you, I think you could just go use the ECS crate.
Well, and especially if they're separate crates, obviously
They are.
there's a way to do it. But you might be reinventing.
There's definitely a way to do it.
You might be reinventing the other crate.
Yeah.
Is this
It's
how?
like, why not just use the Bevy app?
Yeah. Is that how reactive apps would be made then? Like you run your own schedule based off like when values change? So this one's like immediate, right?
That's
So
like
it's
the
running
JavaScript event loop, right? It's
Yeah.
like,
Are you
everything's just
asking-
static until an event comes in and then it changes.
Oh yeah, so that one's event based, so it doesn't wait. Well, I was thinking of React. React is the thing where it diffs every time a value changes, like it has the B DOM and then it diffs those.
Yeah,
two
I guess I'm
states.
just talking JavaScript proper. Like in the browser,
Yeah.
the page is just there,
Mhm.
and there's an event loop. And
Right,
so
but
an
that one
event
runs
comes
60
in.
seconds. That one's runs 60 times per second, right? Or whatever the frame rate is
I
of the
don't
computer.
know.
Bevy's,
So
Bevy's will run.
that one's immediate mode.
Bevy's will run as fast as you can. Let's see it.
Right. So that's what I'm saying. So if you wanted to make an app that didn't consume all of your resources on your computer, could you run your own schedule to say like, I only want you to run when this changes. That way, I only have refreshes.
Using the Bevy app, is there a built-in behavior that does that? I don't know.
Yeah.
Could you make one? Sure.
Makes sense.
It's very accessible.
Yeah, I don't know. Yeah, I don't know if there's a built-in way to do it. I mean, you can set the frame rate very low.
Mhm.
Can't do that. I know.
Mm.
Yeah. All right. Let's see. This guy says thanks. I'll check out schedulers. Yeah. All right. Let's see. What am I sharing? I'm sharing that screen up there. So it's been a pretty picture most of the time. Well, for the last little while. Why don't I switch this back to mirroring so we can go through our code examples. Closer slideshow. Stop sharing so we can switch to mirroring. Stop sharing on Zoom. I also got OBS. Well, let's switch the screens. Let's see what OBS does. Actually, let's switch OBS first so it doesn't like crash or something. Okay, let's see. Displays. Pick the big one, change it to mirrored. Alright. Now you should see that, and then OBS, I should be able to switch it back to like, whee! And then Zoom, we can reshare it. Yeah, okay, and then we'll get off of it. We'll get on to Fighter.
Those things used to make me nervous. I thought I would like break something by creating them.
Alright. Well,
The
it's
first time I
called-
used OBS,
Like-
I was terrified of that thing.
Okay, I just made a new Rust project called ECS. I'll just make this bigger, full screen. Okay, Zoom, can I get you out of the way, please? If
Isn't there like
I
Should
hide
be able to.
floating meeting controls.
Oh.
Yay, okay, that's close enough. Okay. Ba-dum-ba-dum. So we'll go cargo, oh, let's go to demo mode. Cargo, no, not cargo new, what am I doing? I'm doing
cargo install? No, it's not.
cargo add Bevy.
What was that demo thing you just did?
Yeah, side note, what is
know.
that?
That's just a bash alias that changes my prompt to get rid of all my extra information.
Oh, I see.
Like my path.
So it just changes your PS1?
Yeah, exactly. to just the current directory. It's like in demos, they really don't care what my username is, what machine I'm on, what directory I'm in, or
Yeah.
what Git branch I'm in, or the status of my
all the
last
fancy stuff
command.
in
Or,
yours while you're
yeah,
developing. Yeah.
it's like useful to me, but while I'm demoing, not so much. Okay, so we'll go cargo build just to get the dependencies compiling in the background, and we'll go here to our main RS, and we'll get rid of that, and we'll go use Bevy prelude star. We got to wait for like everything to catch up here. And okay. So what do we want? Oh, thank you,
Copilot's
Copilot.
gotcha.
Okay, so Bevy's app is app, and we'll get syntax highlighting here someday. And then you call actually, that's close, but I want new. And then we do want to add plugins, default plugins, that's correct. We do want a startup system, don't need that anymore. Copilot's not quite right. Okay, so we're gonna make a system here called setup. And that's not quite right, actually, that's old Bevy. Add systems. We would see once it catches up and I can do our syntax highlighting, we would have seen that it was wrong. So in the newest versions of Bevy, you say, okay, I'm gonna add some number of systems to a startup stage, and they'll call them just once. As opposed to regular systems at the update stage are called every time it updates the frame.
Is startup in enum?
Startup is a struct.
Oh, okay.
Oh, struct startup.
What's the signature of add systems?
Yeah. So systems takes a schedule
Okay.
and then your systems.
Okay.
And then you can see it, if you look at that a little closer, you can see their trait magic.
Is it
Anything that implements schedule
Implements
label,
schedule.
anything
Schedule
that implements
label's
into system
schedule
configs.
label is a trait?
Yeah.
Yes.
Mhm.
So they've got a bunch of built-in stuff. Like you could chuck all that and like make your own scheduler, like in your own schedule stages. But like they have all the built-in stuff that you need for a game. So the two
I
that you
see.
care
So
about
it's
are
extensive.
startup and update. That's all you gotta remember for a basic Bevy project. Stuff at startup runs
So-
once at startup, and update runs every frame.
I'm new to Rust, so I'm just kind of putting these pieces together.
Well, this
So startup is a struct that implements the
the
whatever it's called,
the-
schedule
yes.
label trait.
Exactly. That struct implements the schedule label trait.
Okay, I'm following now.
Okay.
Thank you.
All right, so we're gonna make this abstract. We're gonna take a mute commands, which is gonna be our commands struct. That lets us access the ECS directly, so we can do stuff like spawn a. That's almost right. It's not quite right. We want to spawn a 2D camera. I don't think that's the one. Camera, is it? A camera 2D dot. That's the one. Okay, so that's just gonna give us a 2D camera. And default plugins is going to be like, oh, we're going to hook up the keyboard, we're going to hook up rendering, we're going to hook up the audio subsystem, stuff like that. We're going to hook up the asset pipeline so you can load assets from disk, stuff like that. Stuff that pretty much everybody wants. Commands, like I said, is so you can access the ECS. This is going to spawn a bundle of components. So bundle is just multiple. So spawn, actually, is that there still? No. That's old as well. Copilot's behind the times here.
Wonder why
You want to do spawn.
Analyzer wasn't.
Yeah, you should restart your
And then
Rust server.
insert.
Oh, well, it catches that.
Okay,
Yeah, now it's like, bro, what's this?
no, we just do it straight to spawn. They changed the signature so many times I can't keep up. Okay, there we go. At one point you had to spawn and insert, and then there was spawn bundle, and there wasn't spawn bundle. I don't know. Okay, so we got a 2D camera, and let's add a resource. I think that's insert resource, and there is a clear color resource. Great, that's great. Let's make it more bluish. Okay, what did I do wrong?
Is your indentation weird?
No, indentation's weird because I don't have enough friends. Here we go. Okay, so the built-in rendering with built-in cameras looks to see if there's a clear color resource. In fact, it has its own. It'll set one if it's not there. It'll set it like black or gray or something. But we're going to set our own so that it uses our color to clear the screen instead of the default color. So this should be enough to get us a window with a color. Ooh, we're in full screen. There we go, a window with a kind of bluish color. All right, let's get this out of actual full screen so that it doesn't keep switching back and forth.
Hang on, why was it showing that in the background?
Showing the blue?
Yeah.
Because we added a clear color. And by default, the cameras look at the clear color for every time they redraw the frame, they start by clearing the screen to that color. And then they draw
Oh,
the
you
whole-
created a clear color resource.
Yes.
I see. Okay.
Yes. Okay, so ECS stuff, what do we want to do? Well, why don't we get a sprite and display it on screen and do something with it? So, commands. Oh, we're going to need the image. So, let me go grab. What? There we go. Dropbox, graphics, props. Let's get Ferris. Okay, and then we're going to put Ferris in the assets. So all the assets by default, unless you configure it differently, need to be in an assets folder, just named assets. So we put it in assets. So now we got this little Ferris image. We're going to spawn a sprite bundle. No, that is not recent. Copilot's like behind the times. Sorry, Copilot. Here, I'm gonna do
It's
this.
another example of whatever you do for your users, you do to them.
Yep. It's like, oh, Copilot's great, but I always have to read it to see if like, how great is it?
So what's the difference? I thought I saw when your autocomplete had Sprite and Sprite bundle. Are both of those a thing, and what's the difference?
The Sprite bundle includes a Sprite component, but all the other things you need for a Sprite too. So like you need way more than just the Sprite component. So you usually wouldn't use a Sprite component directly when you're spawning it. You might grab the Sprite component if you want to alter it, like to change the tint on a Sprite or something like that. But usually what you'll really deal with is the transform, the location, the size, and the rotation of the Sprite. That's what you usually care
Okay,
about.
so the Sprite bundle includes other components.
Yeah, all these components.
Can you click into it? Oh, never mind. It has.
All those.
Yeah.
But the only ones I actually want to customize are transform and texture. The texture is the image, and the transform is the location. The rest of them, I'm going to leave default.
Huh.
It'll set them up for me. So the transform, that's the location. So almost. Transform from XYZ is the new name of it. It's like it's reading from Bevy a couple versions old.
Yeah.
All right, so let's put it like negative 200 and 0. So it's going to be on the left side of our window, and the z is just going to be 0 because we're 2D. And the texture, that's the image. So here we're going to go, we need access to the asset server. So we're going to go asset server. What do you think, Copilot? That's correct.
Wow.
And other stuff.
I don't need the other stuff though. Anyway.
Can you push like command arrow to
Probably.
or control arrow to accept like just some of that completion?
I don't know. I haven't tried.
Never tried.
What am I getting? Asset server.
It really
Control
wants you.
arrow?
It really wants you to use that
Control or
material.
command.
Not control arrow.
Depends on
Command
what.
arrow.
Or,
Command arrow.
yeah.
Today I
Could-
learned
could- it'd
from
be-
you.
It'd
Thank
be
you for
control on
teaching me that.
Windows, command on
That's
Mac.
awesome.
Okay, so asset server is one of the built-in resources for loading all sorts of different kinds of assets, including our images. So we're going to take our asset server, we're going to load, and then we're going to say, it's already looking in the assets folder, that's why we put it in there, so we just have to go Ferris, flat, happy, PNG, and guess how it determines the file type?
The extension.
Extensions!
Wow.
Wow!
Amazing.
It's like the 1970s all over again. Anyway, what did I do wrong? Probably.
Probably because of the return type.
Yes, thank you. Okay, so there we go. We load the image, we'll put it in a place, and let's go run it. Bing. Okay, so the spawn implicitly spawned an entity, and then we gave it a bunch of components which it attached to that entity, and they all have all the stuff it needs to display a sprite, and that's nice. So now we can make another system that queries for that and does something fun with it, right? So let's go do that.
So spawn creates the entity.
Correct. Spawn will create the entity. Doesn't tell you about it, but like it might return.
So do you ever interact with entities directly, or are you always just interacting with?
Not usually.
components?
You're usually just doing a query, and they're implicitly there. Like sometimes you might go grab the entity ID in case you're just like, you know what, I want to store the entity ID, and at some point just like go get it directly from the ECS. It's like I just give me all the components for this entity, or something like that.
One example I had was I wanted to have like something attacking something else.
Yeah.
Right?
Yeah.
So you have to store a reference.
Relationships.
Yeah, you guys have to store a reference to like whatever that other thing is to in the future go grab it, right? So if you say like your component is attacking, you'll usually say like target the ID of the other entity,
Mhm.
right? So then you'll go
Because you
inside.
can't get a reference to their entity.
Exactly.
just
You need to
store
use the entity to get a reference when your system is called.
when you're ready to,
Mhm.
to
Exactly.
subtract life
Yeah.
from the thing that you have or whatever.
Yeah.
Okay.
So you can think of the entity idea as the address where I can go find all the components for this entity. Kinda, sort of. Anyway, okay. So let's make another system. Let's move the sprite across the screen, right? So I don't know, move sprite. And let's see, what do we need? Oh, okay. Yes, we need time. Yeah. Oh, I like it. I like it. That was a good one. Okay, so we got a time resource. That's so that we can use the delta time since the last frame to multiply things so that our movement is smooth. Here's our query. So we just called it query over here, and then we got query, and then in our brackets, okay, so we're gonna say I want all the transforms and the sprites. Now I don't actually need the sprites. In fact, there's only one thing with the transform, so I could just say literally just give me all the transforms, and I'm gonna move them all because there's only one. Actually, would I move the camera? I might move the camera. I don't know. Let's make sure. Okay, so to make sure, let's go.
The transfer is attached to the sprite, right?
A transform is connected to the sprite. The
Oh,
camera
you're
might have a
getting
transform.
all the things that have a transform.
Yeah, so you gotta be careful. You gotta think about like, okay, how do I know I'm getting only what I want? So let's make I don't know, crab. No, Ferris. No, sorry.
Derived.
Right, Ferris.
Oh, right. I'm getting ahead of myself here. So this is just a marker struct so far. It doesn't have any data. But now we can say, okay, since it doesn't have any data, I don't actually need to get the data, so I'll just say with Ferris. So give me all the transforms, but only if there's also a Ferris there. I don't need the Ferris. Just it needs to be there.
So how do you attach the Ferris?
That is an excellent question. So what you do here is this actually can take either it can take a a component or a component bundle, and tuples of bundles or tuples of sprites are also bundles. So we just make it into a tuple and add Ferris, and then it'll reformat here for me. There we go. So now we added up all the components from the sprite bundle, and we added a Ferris component.
So spawn created an entity.
Correct.
It created a row
Correct.
in the table. And on that row, we're giving it a sprite
These are the columns.
So you're giving
and
it
a Ferris.
Yeah, well, and the sprite is actually a bundle of components. Remember we
right.
saw those
It's
like
giving a
6 or 7.
a couple of columns.
Yeah.
And then one of the columns is going to be Ferris.
Uh-huh.
I see.
And a
which
Ferris.
is essentially a Boolean or
Basically, well, it has it.
right.
It's present there at compile time. At runtime, it's not.
It's a zero size
Yes,
structure.
it's zero size type. It knows it's there somehow. Magic. Okay, so over here, so to loop through this, there's only a transform. So I can get rid of that. There's only a transform. And I have to put this mute in front of it. Is that true? Do I have to put the mute in front of it?
Are you
Yeah.
I think it's immutable. Maybe we do it with me in front of it. Interesting, okay. That's some part of ECS magic, not exactly sure why that needs a mute there. Oh, it's because it's gonna change the, even though it's a mutable reference, it needs to change what the mutable reference points to as it loops through it, that's why. But it's, isn't it inside of it though? I'm so confused, I don't know, don't listen to me. Okay.
Sometimes you just do it.
Whatever the case, you do, you have a mute there, you take the transform, get its translation, we're gonna get its x value, we're gonna, okay, 100 pixels per second times the delta, that is perfect, that's great, that's a great, let's sort of move about that fast. And then, oh, I like this, let's move this to more like 450. So this right here is saying, okay, well if our x gets over a certain value, let's reset it back to the left side of the screen. So like we don't just go off and lose it.
We'll kind of wrap around.
Yeah, wrap around. All right, let's try it.
Do we add it?
But it's not.
Did we not add it?
It's unused.
Oh crap. What did I do?
Well,
You-
do
you
you have
need
to
it
like
up.
look it up somewhere?
In
You
main.
need an update.
Oh,
probably
thank you.
somewhere, right?
Yes. Okay. So, add systems to the update stage. That's correct. That's right. Okay. So now it'll be called that return. Bing.
Aw,
Ooh.
Magic.
that's beautiful.
And then of course, like the transform also has rotation and scale and stuff. So like, transform dot rotate. Oh, it's not right. Rotate around the z-axis. I don't know, 1 radian per second.
So the rotation is radians.
Yes.
So if you want to do degrees, you'd have to do that.
You'd have to do the math yourself if you want to do degrees. It's all radians.
Makes sense because that's
It's what
that's
all the
that's what
calculations
should
really
do.
want to use.
No!
Go, Ferris, go!
It's a tumble Ferris.
Other than like 1 radians, kind of a weird number.
Let's see, let's see. Transform scale is equal to, what should we make the scale?
You should modulus it so it goes up and down.
What's that?
You should
So
modulus
like-
it. Yeah. So it kind of grows up and goes
Okay,
down.
I love it, I love it. It should be the transforms translation x value mod,
Oh, that's kind of tricky.
mod something?
That's something.
Mod
Well, it has to be
100 over 100.
Yeah, you just have to times it by.
plus, but divided by 100 because we scale, divided by 50 plus a little bias so it never actually gets to 0 because that would be bad. Let's see if that, what did we do?
So it'll grow big and then shrink.
Oh my gosh!
Oh, there you
go! That's terrible, I hate that. What were you thinking?
Because the negative side
Oh
is
my
opposite of what it does.
Oh my gosh, what did you guys do? Okay, you know what we're gonna do?
It's just pure chaos.
Just model.
Sign. Ah, okay.
Oh yeah.
Oh, that's so much better.
I think I'm gonna
I
like
would
this
never
better.
thought of that.
Okay, maybe we should spell it out. The x divided by or times 0.01 sign. How was that?
Yeah.
Would that slow it down? Am I mathing this right? Yeah, I'm gonna speed it up.
We'll see.
Yeah.
Oh, I like.
And now he bounces.
Okay, so when it's a negative scale, it actually flips the whole sprite image.
That's funny. That's funny.
Oh, interesting.
That's beautiful.
Okay, well, hold on. But we want to. This is a game, right? Why don't we do like some input? Come on, Copilot. Oh yeah, that's okay. That's close enough. It used to be, that used to be right. Now it's button input. Okay, let's make this vertical. I knew it would. There you go. Okay, now if we say if input just no input is pressed right now, the key code space, yeah, space bar. So only if we press the space bar will you move. What the? What are we?
It took your
You,
Filled
translation.
it.
Yeah.
you completed everything inside of that if statement that you suggested.
Wow. Okay, that's what I wanted to do, but you didn't take this part out. Okay. This is the same, right?
Yeah.
I don't know. It's a lot
Yeah,
of
you're gonna have
trust,
to
but-
press the space a bunch, right? To
Or you just have to hold it down, right?
No, it's just checking. Is it pressed?
oh, it's not just pressed. So you're hitting
Oh.
play.
Oh.
Nice.
Oh, magic! It's so funny because like developers are like, oh! Just like you show this to like, I show this to my kids and stuff. And like,
That's
why does it
lame.
take you so long to make a move? Why does it only do this? I want it to move around.
Yeah.
But you can see where it's like, okay, I start looking for arrows or WSD, ASD or whatever, and I have it actually move in specific directions, do specific things. I build the logic up, right? This is all the basics of Bevy, and you can see how it's all built on the ECS, right? Now that you know, oh, there's these things stuck in resources that you can access to, like the input for the keyboard and the mouse and the gamepad and blah, 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 blah.
And so
And-
that's just magic you ask for by declaring a parameter.
Yeah, and guess what
And
we
okay
don't have to
too.
worry about? Ownership. Because the ECS took, like, the actor model ownership is just a nightmare in Rust. Because, like, because with the actor model, like with Unity and Unreal, they're just playing fast and loose with pointers. Oh, just pointers. Yeah, something may take it away and I'll just need to remember to check and see if it's null,
Yeah.
right? But in Rust, it's like, I'm not going to compile, forget you. So like it's a nightmare in Rust to try to build a game engine without an ECS because like I want to have this guy be able to access this other guy and change his health. How? I don't own the other guy, right?
So Rust reveals the problem with an architecture that's very much like informed by object-oriented programming that creates basically a tree data structure.
Yeah.
Not just a tree data structure, but like more like a graph,
Yeah.
right? And so, and we learned from Rust, if you try to do graphs in Rust,
It's gonna make
It's
it hard.
and it's hard for a reason
hard.
because architecting things that way
Yes.
is
In fact,
problematic.
ECSs are fantastic for modeling graphs, in my opinion,
Yeah.
because you can use the entity IDs as your relationships, and then you just have you have the ECS store them all, and you query the ECS whenever you want to traverse things. Oh, I'll store the entity. That I'm connected to this other node, so I'll store that entity here, and then when I'm here and I want to traverse the other node, I'll get that entity. I'll blast in the ECS for the next one, and I'll deal with it. Now I have him, and I'll do what I want to do. But yeah, like you said, like trying to do it yourself. Really, the only way to do it yourself is to be like, okay, I'll make these vectors. I'm going to make an ECS myself. I'm going to make a vector of IDs, and whenever I want something, I will go get it from this one vector where I actually store it. But everywhere else, I'm using IDs to represent what's where. And it's just like, oh, nightmare. And as soon as it gets complicated, it gets complicated fast. So yeah. So anyway, that's all I had planned for myself. This took me way longer than I thought. I thought it would be like half hour and like done. Good thing I didn't plan my bigger.
Yep.
This
Short
was
and
great,
sweet.
though.
Well done.
Yeah.
So yeah, what the plan is like 1 of 6. So the next 5.
1 of 6.
Yeah, is that what the title said?
Yes. So I think there will be roughly 6
Give it a
Bevy
chat
things.
message.
Let's look at the chat message. Just a second. Before I do the chat message, I'm going to switch OBS to show just the camera, and then I'll switch it over to like show all your pretty faces. Okay, it's just showing the camera now, and Zoom has a camera, so now I can be like, hey, look, let's look at the room, not just stare at me all the time.
Yeah.
Wow.
Wow, we have a room here. Yeah, I think we can literally fit everybody in that picture. Okay, well, where were we?
Chat.
Chat. Oh, looking at Zoom chat. All right, Zoom chat. What do we got? He found the cheat book for schedules. He was looking at schedulers.
Oh.
Very
Cool.
nice.
Good on ya. All right, we just got 15 minutes left. Shop talk. We can keep fiddling with this, or we can talk about whatever.
I have a very specific question.
Specific question.
That's
Go.
just a game
Taylor.
dev question.
Yeah. Me and my 0 successful games.
You made $7. That's $7 more than probably anybody in this room.
It's true.
It is.
Yeah.
Yeah, $7 more.
There you go. I am the certified $7 expert. If you want to spend 15 years on game development and earn $7, do what I did.
Yeah, you're a veteran. That's crazy.
That's hobby dev.
Yeah.
So, say you have a game where you have mouse controls
Mhm.
that will work in your world,
Yeah.
and then you have a HUD,
Mhm.
and the mouse will work on the HUD also.
Yep.
How do you make it so that if the HUD handled the click, that the world shouldn't handle the click underneath
Sure.
it?
It's called logic. No.
Okay.
Sorry, I mean physics. Okay, so there's a real question in there, which is really like, how do I change like what's, like I'm in a game or I'm in a menu. And that's a
Right.
really common case. And like when I'm in the menu, maybe I don't want the game to like proceed. Like there
Right.
are, what do they call them? It's not stages. It's okay. They had a
States.
concept in Bevy, and then they changed it, and I'm not sure where they ended up because I haven't tried to use it. But there's some way to say like, yeah, states.
States.
I think it's a state. Yeah. So look up states in Bevy.
Mm.
I don't remember where the implementation ended up, but you should be able to say like, okay. Oh, I know you can. There's a way to say like, I want this to run at engine startup, or I want this to run at state entrance, or I want to run this during the update of the state, or I want to run this at the exit of a state. So what you would do is you'd set up your systems so that like when you're in the menu state, you run your menu systems. So your menu systems look at the input. And when you're in your game state, then your game systems look at the input.
So what,
Interesting. So that would work for like I've pulled up the menu, and I want just to do the menu.
so like you pressed a button that pulls up your inventory screen or something,
Right.
right?
But what if I have HUD elements and the game elements, and I want to be able to do one or the other based on where the mouse is clicking?
Well, then you're probably going to have just one system look at the location of the mouse
Okay.
before
Okay.
it does its thing.
I think.
And then it's like, if we're in this location, handle it for this, and don't handle it for the underlying game.
Mhm.
If not,
Or it
then
might even be a little bit more complex, where like maybe your HUD is dynamic based on the size of your screen or the shape of your screen. And so maybe
Right.
you actually need to run a query where you say, what's here at this screen position? Is my HUD here? If so, then I'm going to pass this input to my HUD.
Yeah.
If not, then I'll just pass it back to the game.
So,
interesting.
So like you're thinking of,
So Flutter, which is kind of like inspired from web, they usually do this concept of they have events that they pass down the tree. So if you get a touch event, you go to the end of the tree, right, and then you start passing it down, and
That's
then
super
everybody
common for
says,
UIs.
yeah,
Mm.
everybody says like each node gets a chance to say whether you consume the event or you don't, like just pass it on.
Right.
It's not my deal.
Mhm.
So for somebody who does consume the event, the event would stop right there, and the background wouldn't get a chance to even look at it. So they might have something like that.
Well, the UI does, but he's talking about a step above. Do I pass the event to the UI? Or
Oh, okay.
Right?
Yeah.
And
Because
so
That's
really,
interesting.
it's similar.
it's like
It's
like
similar.
you have like
Conceptually-
a toolbar or something, right?
Yeah, yeah.
And your world's being rendered behind it,
yeah,
Uh-huh.
yeah, exactly.
probably cold or something maybe, but
That makes sense.
but it's kind of there, right? But your user clicks on a button, there's a monster that's right immediately underneath
Yeah.
the button.
You
But
don't
you don't
want
want
to
to
click the
interact.
monster.
You don't want to interact with that, right?
Yeah.
Yeah.
Yeah, that's the situation. But that makes sense. Just kind of like, okay, like have logic, like okay, on a mouse click. But this is interesting because with the systems, you can have systems that encompass everything, like the
Yeah.
HUD and the game together
Yeah.
for that click, and they can decide like what the click means
Mhm.
for the whole thing. Because I'm in a situation where it's like I have two functions, one for that updates the UI, and one that updates the world.
Right.
And so the way that I'm going about this problem is really quite hacky. I basically have a data structure of mouse clicks, that I'm passing in, and then I'm going to mutate it,
Ooh,
and then pass it back out, and then pass it to the next one.
interesting.
But I don't know if that's the right solution. But it's kind of similar because it's like, do you want to handle this? Yes.
Uh-huh.
Oh, you handled it. Great. You know.
Well, there's a lot of solutions. It's up to you to determine which one's right.
Yeah. But this is interesting. I was just curious how Bevy would solve this,
Right.
because it seems like with Bevy you could have systems that are like, this is a world-only system, right? Like this is only running to do stuff in the world. But you could also have systems that encompass more pieces and handle things
Yeah.
differently, which is really flexible.
Yeah.
Yeah, and having something similar to what he explained, where like one system says, "Oh, I consume this input," and then another system or another part of the code says,
So that's a thing?
I don't. I'm saying you could write the logic to
Yeah.
Oh, okay.
to implement that.
Oh, okay,
Right.
interesting. Yeah.
Oh, yeah, maybe it's built
So
in.
you
to
have the
the-
struct that contains mouse cursors, like a mouse cursor event, and then you transform like the location of where the cursor is or something like that?
I'm making a struct that is my mouse buttons.
Okay.
And I have bools for this button is being held, it was just pressed, or was just released.
Oh.
And then if I handle one,
Uh-huh.
I drop it to false.
That's kind of stuff. It's really nice to let somebody else write, so you don't have to do it.
Yeah. I'm dropping it to false so that the next thing that takes an update will think that the mouse isn't even pushed
Mhm.
Mm.
So I
because
think-
somebody else handled it.
Yeah, I think there is a crate called like Bevy mod input or something, Bevy mod mouse picking, that does that. And what it does is essentially cast array, and then whatever that hits, like it might be world space UI or it might be
Mhm.
like something in the like actual world, but it casts array, and the actual logic of how you cast that array is like up to the back end implementation.
Yeah, it's just a matrix.
And then whatever hits it, right? That first entity that it collides with, that's what that's what the user interacted with.
Right.
All right, so you might look into that. I don't know.
Well, this isn't in Rust for one.
Never mind. What is it in?
It's in Go.
Oh, okay, that makes sense.
I'm using Go and Raylib.
Oh, they have bindings?
Yeah, they're really good bindings.
Yeah. Don't they generate them?
No, somebody maintains
Ah.
probably the best bindings of any language
Yeah.
I've seen. Like,
What's Raylib?
so Raylib is a really bare bones game library.
So more like a media framework?
Kind of. It's at the layer of like open window, start drawing, draw line,
Mhm.
draw sprite, end drawing kind of thing.
Yeah, that's what I call a media framework.
Yeah, so it's not an engine by any means.
Like I can draw graphics and do sounds.
Right. Yeah, it's at that layer of like here's just a big library of
Mhm.
stuff you can do at that layer of abstraction basically, and then you do the rest. Like you make your game loop, you make your updates, etc.
So I still think that idea will work though. You can cast array from like your UI camera or whatever camera that you're looking at, from like the origin, and then straight out into like the world. Then whatever it does interact with. I think that will like apply to most situations if it does have that. kind of stuff.
I will look into that. Yeah, because what I have now is that the world is being drawn in a camera space,
Mhm.
whereas the menu is just being drawn.
Yeah.
Like on top of.
Never mind. I don't think that'll work.
So.
UI is often not in the camera.
Yep.
Right. 'Cause it's in its
Right.
own-
Unfortunately.
it's its own space.
Unfortunately, I think. Like I came from Flutter, and like that crap, like they realized like their own downcoming like a couple of years ago, where like they realized like, oh, everything should just be 3D, and then we can like compose it into layers like that, and we get like a bunch of stuff for free. No, they had all these like 2D ideas like from the start, and they architected that in like deep down, and it's just it didn't age well.
Interesting.
So anyway, yeah, that's interesting.
It is interesting. I agree. Yeah, this makes me. I wouldn't say like I'm not recommending you should do this, but it made me think of the fact that you can make systems dependent on other systems, so that one system runs before the other system. So that
Okay.
you can actually coordinate. Like, let's say, oh, these two systems both need to access the resource. I need to make sure like this system accesses it first and does its job before this other system. You can actually order the systems.
Okay.
So is that like for like if you do collision detection, then you want to do movement first, and then detect collisions or something,
Yeah.
as a example.
Like if you want to get real into it, you can like access different stages of the pipeline even, but we usually don't do that. Like just right here, where we're putting startup systems.
Isn't it just run in that order, top to bottom?
So all this stuff in the update that I'm stating in here at the same level runs at the same level. So like if I did like I don't know, other system, these would run in parallel if they could, or in an undetermined order if they're dependent on each other. The ECS won't run them at the same time if they actually access the same data in the ECS. But if they don't access the same data, it will literally run them in parallel if it can. It'll run a whole bunch of systems in parallel. But if I say this, then this system will run before that system.
Oh.
And this system will run at the same time as move sprite if it can, or some undetermined ordering if it can. So you can actually order it like this, just with these nested tuples, and then the earlier tuple entries will happen earlier. So interesting. And then that's just like if you want like this is sort of a shorthand. There's also let's see if we'll do it. You can say after or before and like specify the other specific system set, which is one or more systems. So you can also say that like I'm in a set, I'm in set whatever. So like it has all these ways to like label sets and say they're before or after other sets and stuff like that. Because in real games, ordering is often important. Like, oh, I better go figure out how much mana you have and decrement that mana before the spell activates.
Right.
Yeah.
Don't want to get into negative mana.
I mean, how do you even represent that? Does the bottle like have a hole in it?
Or you're using an unsigned, and so you just have full mana.
Wow. Ooh. That'd be great. My madness. Through the roof.
Wasn't there like a bug in one of the Sid Meier's Civilization games?
I'm sure there was.
There was one. So Gandhi was like the most peaceful of all of the NPCs.
I have heard of this one.
And there was something that would make him even more peaceful.
Yeah.
And it would roll over, so he was like a psychomaniac.
I was reading something recently that apparently is an urban myth.
Really?
An urban legend, yeah.
I remember just hearing and thought it was funny, like that, like Gandhi's aggression level like rolls over to be the
They
maximum.
talk about a bunch of that kind of stuff in the book that Sid Meier wrote. I should go get it. It's been several years since I read it. He wrote like a memoirs, but
Does he talk about like programming shenanigans and
Yeah.
game dev? That would be cool.
did
I
he
wanna-
write a book? There's someone writing about it. I don't remember.
I want a book detailing how the roller coaster tycoon guy did what he did.
My gosh.
There's another urban legend of, I think it's Team Fortress 2, that apparently their code was just so convoluted that in one of their assets folders there was a JPEG of a coconut. Just a
Oh,
picture. It was like wasn't even used or anything, but like if you deleted it, the game would crash. It just wouldn't run. I think they later debunked it that like you can like delete the entire assets folder if you want to and it still runs. But for the longest time people just believed if you delete the coconut, game doesn't work. No one knows why.
It's hilarious.
That would be easy. It'd be hard coded below the coconut. If it's not there, it crashes.
I'm pretty sure
Pretty
that
simple.
that like in the TF2 source code, there's a lot of like comments that are just like, I don't know what the F this is.
It works.
Have you seen?
Don't delete this
Don't
line.
delete
Have you seen the comment to like Doom's Quake 2 algorithm or something? Not what
Oh,
is it called?
are you talking about
The-
inverse
Oh,
square
the
root?
inverse
Inverse
square
square
root?
root.
Yeah.
Yeah, so there's like a little comment above it, and then like you're like, oh whatever, and then like you see the YouTube video of you're watching it or whatever, and it's like 50 minutes long, and you're like, oh my
Right.
gosh,
Yeah, it's crazy
what's
stuff.
this thing?
The inverse square root is quite the
All right, folks.
quite the
Yeah.
behemoth.
It is time.
Yeah.
I'm going to call it. Thanks, everybody.
Thank you very much.
inverse square root makes sense when someone explains it to
Like
you.
someone they walk you
Just
through
walk
it,
you
you're like,
through it.